on the surface of the earth, whatever we are doing, the one thing that we will experience is atmospheric pressure. That is, above the surface of the earth, we have an atmosphere. It is filled with stuff, and this stuff exerts force on us, and that can be calculated. The amount of force can be expressed in terms of pressure, right? So force per unit area, that can be calculated, and that we are calculating using something called as common barometer, and this uses the fluid's properties per se. Okay, so we are looking at another application of fluid over here. So we are reusing the Pascal statements over here. Okay, yes, and this is known as common barometer. So the purpose is to measure atmospheric pressure. So basically, a common barometer, it consists of a long, narrow glass tube like over here. So that's your glass tube, closed at one end and open at the other. That's important. The tube is completely filled with mercury. So this liquid turns out to be mercury. And then inverted carefully into a mercury, right? This too is a container with mercury, without allowing any air to enter. So when we do this, what happens? You think all of this comes out? Do you think they pour out? Actually, no. It kind of stays at a particular height. When you do this, right? We'll also do this, not with mercury, I guess, with something else. Some dense liquid. So what we'll get to see is that not the entire thing will come out, So, traditionally what we might feel is that actually we can do it with mug and even water, honestly. Even that is possible. So our intuition might tell that, the entire mercury should come out. It does not. The tube will have some amount of mercury in it, and using this, we'll be able to figure out the atmospheric pressure. So let me put it this way. See guys, so we get to see a column of mercury hanging over here. But how is that possible? How can something stay over there? Means what? There has to be some force that is keeping it up or pulling it up. So obviously there's nothing pulling up. Here it will create a vacuum, honestly, because initially it was all full of mercury. When we dipped it, right, we were careful not to allow any air to enter. So there is no force over here. So the force that keeps this up has to come from a push, right? So basically over here, there has to be a push, right? If you guys see something standing, what does it mean? Means someone is either holding it, right, pulling it up, or pushing it up. Either one of that has to be true, Either you are, say this is a bag and you're holding it, or it is on your head and you're keeping it on your head, or a table or whatever it is. So someone is pushing it up or pulling it up. So in this case, we are pushing it up. But who is where is this force coming from? Well, the clue is over here. Point B. So we know that the pressure at a given height has to be same. So at this height, the pressures have to be same. Actually, any height, the pressure will be the same. So at point A and point B, the pressure will be the same. Means what? There's a force over here, right? That force, that is nothing but your atmosphere pressure, is keeping this liquid from overflowing. And this force is transmitted to keeping this mercury up in this tube. It might not be this dramatic, honestly. Okay, actually it is 76 centimeter. It is actually that dramatic. So you get to calculate, you get to see that this is 76 centimeter. If you use the mercury and the density is some X value, I don't know what is the density. So you get to see that this is around 76 centimeter if we do it properly. So it is dramatic actually. 76 centimeter is not a small length. So the cause of this is the atmosphere. The atmosphere is pushing this liquid down, and that push is transmitted to here. The mercury column being upheld. It's held over here basically. So that's the whole funda. So by measuring this height, we'll be able to figure out the atmospheric pressure. I'll do the math, then you guys will understand. So that's your construction. Okay, there's nothing for me to add. Let's go to the working. The closed end of the tube is nearly a vacuum. So the pressure at the top of the mercury column can be taken as 0 because it's vacuum, and so there's no push per se from there, right? So this is vacuum. So there's no source of push from there. In figure, the pressure at A due to the column of mercury must be equal to the pressure at B due to the atmosphere, as they are in the same horizontal. So the push down over here has to be equal to push down, then only it's balanced, right? If not, it won't be balanced. So if I'm able to figure out how much push this mercury is providing, the same amount of push can be seen at point B as well. So equal and opposite, they'll cancel each other and things are in equilibrium, right? So that's how we'll be able to figure out the atmospheric pressure. So let's move on. The math would be P is equal to P naught plus rho GH, right? Okay, so let me complete the diagram. So this is my H technically. The pressure over here is, again, call it as PA. And this is P naught over here. So PA is equal to P naught rho GH. This formula we have derived, right? So this is technically PA. But P naught is equal to 0, right? Therefore, PA is equal to rho into G into H. As PA is equal to PB by our understanding, right? Pressure at the same height, because they are at the same height. Same height. Okay, I can just write it as same height. Therefore, PB has to be equal to rho into G into H. And source of pressure at PB is nothing but your atmosphere. So by figuring out rho GH, rho value we know, mercury's density we know, G we know, height we can measure. So when you substitute all of this, we'll get our atmospheric pressure. Okay, so you can web search. That's your homework. So go to the web, search for density of mercury, Hg if I'm right. Then G value you guys know. H value, it turns out to be around 76 centimeter. Convert this to meters and calculate. You will get the pressure, atmospheric pressure. And you can cross verify that with, again, web. Okay. So I hope I made sense over here. It's kind of common sense. If things are at rest, it is at equilibrium first thing. If something is upheld, either someone is pulling it up or someone is pushing it up. In this case, it is your atmosphere. A simple math will give you the atmospheric pressure. And this device is called as common barometer. Okay, so you can pause, have a look.